What if spin means spin? Would it solve a lot of problems in physics? We know quantum particles are both waves and particles. Then the question is, why do waves oscillate? It always seems strange to me that a quantum wave, not a standing wave, would alternate crest to node to trough and repeat. Why would it stop at the top of the crest of the wave and then turn back down? Why would it stop at the bottom of the trough of the wave and turn back up? The solution for me to this and other questions was that the quantum particle does not travel as a wave, but as a helix. We already know the following. When placed in a magnetic field, electrons can move in a helical path, meaning they spiral around a line while also moving forward on that same line, essentially creating a corkscrew-like motion. Key factor for helical motion is presence of a magnetic field, and that's from AI Overview. My suggestion is that electrons always move in a helical motion, but that the presence of a magnetic field exaggerates that helical motion. This seems to both fit what we know and solve some problems. The helix motion would have a wavelength 2. A full spin would be equal to 1 wavelength. It too would have a crest, trough, and node, but they would come from the moving particle in a spinning motion. The helix wavelength would have the same energy as a regular wavelength. Like a wave, the shorter the helix spin, the more energy the particle would have. The helix would also have constructive and destructive interference like a wave. Two particles moving in a helix motion in the same direction would have constructive interference and have stronger magnetic field. Two particles moving in a helix motion in the opposite direction, say around a nucleus in an orbital, would have destructive interference that would make their magnetic field zero. This fits two electrons in an orbital with opposite spin. Next, look at how an electron particle moving in a helix motion would behave next to a nucleus with positive charge. It would be attracted to it and orbit it just as electrons in orbitals do now. Finally, look at bubble chamber photos of pair conversions, where a photon creates an electron-positron pair. See my simplified drawing. Note both the electron and positron spin away from each other from the point where the photon was. I first looked at this and I saw a spiral that turns inward. But what if we are looking at a 3D image? What if the electron and positron are receding from the viewer? Then we have a spiral motion away from the point of creation. If the electron is always moving in a spiral, then we have clues to the meaning of spin, a replacement for quantum wave, new ideas for both wavelength and constructive and destructive interference, and even some possible clues as to how helix direction affects charge. The test of this is if the calculations we know will fit.